Hey gang, Professor Feeser here. I provide education solutions to large groups and organizations. You're searching for a learning pathway for your team or your enterprise. Feel free to reach out. My contact info is at the end of the video. In today's lesson, we're going to talk about decoding HTTPS traffic to HTTP traffic for the purposes of making a Wireshark capture. So the whole world is wired together with HTTPS. That makes it difficult to learn, especially if you're trying to figure out the nuances between HTTP1 and HTTP2 and HTTP3. It's a lot easier if you can look at a PCAP, which can't lie to you, to figure out how does this protocol actually look on the wire when it's like not in a book, but in the real world. Like I said, the security is required in most cases. So what are we to do? Well, Wireshark has an answer, and it's a bit limited. You need to be running Wireshark on one of the endpoints that's actually going to like the client or server side. You need to set an environmental variable that allows you to ultimately decode the traffic in your operating system. But before we get going down that road, let's make a capture of some traffic that's, encrypted. So what I'm going to do, I have Wireshark open here. I'm going to go ahead and apply a search filter, not a capture filter, just a search filter. I'm going to say, just show me stuff. There it is. HTTP, HTTP2, or HTTP3. I'm going to hit the little shark fin to start on my Wi-Fi adapter here. And there's some DNS traffic, but I hit enter, that disappears. It's not that it disappears, the packets are still there. It's not a capture filter, just a display filter. Okay, next I'm going to fire up Wireshark here. And Wireshark, let's just take a little tour. Let's go, sure, weather.com's a good one. And let's click around on, say, hourly. Let's look at, let some things load. That sounds good. Fantastic. Let's go to Blizzard Entertainment. Sounds good. Holiday sale. That's super. Diablo. He's never happy. Not the Lord of Happiness. All right. We'll go to YouTube. All right, that's enough, right? Because you can see in the background as I'm making these clicks, not a whole lot happening. Not a whole lot happening. And that's because the HTTP traffic is all encrypted. The only thing that isn't looks like whatever this HTML canonical pool that was about. So let's redo that experiment. But let's make a couple changes first. I'm going to hit stop on this. And we're going to go into Edit, down to Preferences. Over on the left, open Protocols and search for TLS. TLS. Along the left, TLS. Fantastic. What we want is a pre-master secret log file name set. Okay, and this needs to be in a place that is accessible by Wireshark. If you try this experiment and it doesn't work, try it again with your key log file in a more accessible, like as far as permissions go, more accessible location. I had to try this a couple times before I realized, oh, the desktop is accessible by my install of Wireshark here. All right, so once you have that set, and it truly, we're just making an empty file here. Any name you want is fine. Apply that and say, okay. I touched the file, that is to say I just created, there you can see a file of 0 bytes named the exact same thing. It's just a text document called keylogfile.txt. The magic now comes in setting, we'll edit this guy, an environmental variable. This is called SSLKEYLOGFILE. And here's the deal. If you have SSLKEYLOGFILE set, like that environmental variable set, all of the encryption keys that are built for your HTTP sessions are going to be logged into that file. Wireshark, we told to look to this file for decryption keys. So in theory, we're going to be able to both log decryption keys for HTTP traffic that we're actively generating. Wireshark's going to look to. One gotcha here, gang. I have this set as a script. You could set this as a long-term environmental variable in Windows. Probably don't do that. That's going to be a big security concern. This will survive till the end of my Windows session. If I log out, if I restart, that's gone. It'll stop the logging. If you set this as an environmental variable in Windows, that will persist every time you come back. That will get recreated, potentially a security issue. Somebody could decode your HTTP traffic. All right, let's go ahead and close this. Let's even close Wireshark. I'm going to run the little script. So part of the script opens Wireshark. I'm going to runs Firefox. I'm going to start Wireshark again, now on Wi-Fi. We'll reapply our HTTP display filter and go surfing. Hopefully we see something. There's YouTube. Wow, we're cooking, aren't we? Let's go to Blizzard. Lots of traffic coming back. Click on the Lord of Mondays. Let's go to, where didn't we go yet? Weather. All right, we'll go out to weather. I think that's enough. I'm going to close this. I'll stop the capture. So you'll see in the background, wow, displayed 1,387 packets. If you look here, HTTP2, HTTP3, of course, HTTP is going to be in there as well. But another gotcha, if you're just trying to figure out how the internet works, most of the internet, you can see, is glued together with HTTP2 protocol at this point. So I have some videos coming up where we're going to talk about HTTP, HTTP2, and HTTP3. But you can teach yourself a lot from just this experiment here. Make sure, if you want to be safe, again, when you wrap up, bounce out of Windows or restart your session to make sure you're not continuing to log your HTTPS security keys. Wow, gang, that was fantastically easy and pretty straightforward. Make sure you have permissions or you own the network anytime you're opening up Wireshark or TCP dump to make a packet capture. I hope it was helpful. I hope you learned a lot, or really are about to learn a lot, as you can finally start looking at how HTTP2 and 3 look on the wire. If you did, go ahead and hit like, hit subscribe. I'll see you in the next episode of Code with Feeser.